Okay, 1a, I'm just going to set the r values equal to each other, so I get 1 plus cosine theta equals 1 minus cosine theta. The 1's are going to cancel immediately, so I'll have cosine theta equals negative cosine theta, so I'll just add this to the other side, so that's 2 cosine theta equals 0, or just cosine theta equals 0. So let's see, cosine theta equals 0 when I'm up and down, that's when x equals 0, so that's going to be at pi over 2 and 3 pi over 2. Now I just need to plug these back into one of these ones, but luckily both of these angles I know cosine theta equals 0. So when I plug this in, I'm going to get 1 plus 0 for both of them. So I'm always going to get a radius of 1. So I'll get 1 comma pi over 2 and 1 comma 3 pi over 2. Done. 1b, we'll start off the same move. We're just going to set the r values equal to each other. And we'll combine like terms. So I'm just going to subtract this to the other side. So I'll get 1 equals negative 2 sine theta, divide by negative 2, so I get sine theta equals negative 1/2. That's going to be in quadrants 3 and 4 with a reference angle of 30. So I'm going to have theta equals 7 pi over 6 and 11 pi over 6. So when I go to plug these in, I'm going to remember that sine theta equals negative 1/2. So I'm going to plug it into this one because it's much easier. And I know that I'm going to get a negative 1/2 times 2 is going to give me a negative 1. So for both of these ones, I get a radius of negative 1. And I'm done. So use your previous knowledge to make these easier to solve. For C, we're going to end up needing to use our identity sheet, I believe, but let's just start off same way. Set the r values equal to each other. I'm looking at this, and the first thing I notice is that I can ignore these 2's, so I'm just going to get rid of them. Now I have a 2 theta and a theta. We don't like that. So I'm going to look at the identity sheet, and cosine 2 theta has 3 different ones we could use. I'm going to pick the one that gives me all cosines because I don't want to reintroduce sine and then have to get rid of it later. So this is going to become 2 cosine squared theta minus 1 equals cosine theta. I'll move the cosine theta to the other side. So 2 cosine squared theta minus cosine theta minus 1 equals 0. I just got to factor this guy. So let's see, I'm going to have 2 cosine theta, a 1, cosine theta, and another 1. I need the 2 to be negative to give me the middle term. So that helps me with my sines. So I get cosine theta equals negative 1/2 and cosine theta equals 1. This happens at 0, and only at 0, not at pi. At pi it's negative 1, don't get that mixed up. Here we're going to be 1/2, it's a 60 in quadrants 2 and 3. So I'm going to get theta equals 2 pi over 3 and 4 pi over 3. So now when I go to plug these in, I have to be careful because I have 2 different cosine values for the different angles. So I'll start with the angle of 0, and I'm going to get 1. So its radius will just be 2. So I'll get 2 comma 0. When I plug in these 2, I'm going to have negative 1/2. So when I plug those in, I'll get 2 times negative 1/2, that's negative 1. So both of these have a radius of negative 1. So again, I'm still using the knowledge that I had before to make this a little bit easier for me. But I have to be a little bit careful when I get 2 different values down here. All right, for this one, we need to try to match the equations with their given graphs. And I think it's actually easier to kind of group them by like equations and like graphs first. So the first thing I would do is find everything that was a perfect circle. So that's going to be A, F, and K right here. And then what I want to do is look up here for equations that represent circles. So for example, like 5 is a circle, 4 is a circle, and 10 looks like equations of circles, okay? So what I want to do next is start matching them up. So let's start off with this one right here, perfect circle, radius of 3. So this one right here has to be equation 5, okay? Next, we have this one wrapping around the x-axis, so that's going to be a cosine, and it has a 1, 2, 3. So that one has to be 4, okay? And then this one is wrapping around the y-axis, but it's negative, so I know this is going to be a negative sign with a diameter of 3, so that one matches up with 10. Next, let's look at this one right here, the Lemnis Gate, okay? And its equation has to have r squared. I know this because it's 2 petals, and the only way we get 2 petals is with an r squared for now. So that one has to be 3, and that's the only one it can be. Okay, so boom, done. Those ones are taken care of. Next one I think needs to be this guy right here, the spiral. Okay, so spirals are when r equals theta with no trig function at all going on in there. So that one has to be 16, okay? And that's the only one, so 16 taken care of. Next, I think we should do the rose curves. So that's, you know, all of these guys here. Yeah. So all rose curves equations don't have the addition and subtraction. So when I look at them, they're going to be all the ones that don't have addition subtraction up here. Okay. So I think I would start off with this one right here, along with this one right here. So both of these are a 3-petal rose curve. So they're going to have 3 theta on the inside. And this one has to be a cosine, and this one's going to be a sine because cosine always wraps around the x-axis, and sine always has a petal up here in the first without wrapping around. So if I'm looking at L and the equations we have up here, I'm looking for a 3 cosine right there. So this one is going to be 11, and this one over here is going to end up being 9. Okay. Next, I think I would look at this one right here. It has 1, 2, 3, 4, 5. So I know it's going to be a 5 theta and a cosine. So this one's going to end up being 7. All right. Next, I would look at these two. They have 4 petals, but remember when there's even, we actually only have 2 theta on the inside. So I'm looking for a 2 theta one, and this one's going to be cosine, and this one has to be sine. Remember, cosine wraps around the x-axis. So I'm looking at the ones that are left. Here's the sine one, here's the cosine. Okay, so this guy has to be 2, and this one up here has to be 13. This one has 12 petals, so I know it's going to be 6 theta. It's the only one that's left, so we knew it had to be 12. Last but not least, let's look at all of these ones. They are the limicus, as I like to call them. So that's going to be all of the remaining equations. And I think it's easiest to start with these two right here, which make the heart shape. So that's when I know that A and B values are equal to each other. And I know that this one right here is going to have to be sine because it wraps around the y-axis. So when I look up here for which ones are even, that's going to be 1. So this guy right here has to be 1. This one right here is going to be this cosine, and it's negative, which makes sense because it's wrapping around the negative x-axis. So M is going to be 15. Next, I think I would do this one right here, has the inner loop, so I know that the A value has to be smaller than the B value. So when I look at these, that's going to end up having to be 8. 8's the only one where 1 is less than 4. These guys, the first number's bigger. So I know that that one's there. And then between these two, this one wraps around the x-axis, so I know it has to be cosine, and this one wraps around the y-axis in the negative direction, so it has to be a negative sine. So I know this one will end up being 6, and I know that this one right here has to be 14. And there we have it.